Okay, in this question, you're being asked to draw the products of the following acid-base reactions. Then you're going to label each compound as the acid, the base, the conjugate acid, or the conjugate base. And then you're going to determine the direction of the equilibrium. All right, so here we have an alcohol, and we have the conjugate base of ammonia. So this is our base here. So it's easy to recognize that because this is the species that has negative charge. So I'm going to draw these lone pairs in here. All right, so it's most likely going to be the species with negative charge that is going to act as the base. All right, so we're going to go ahead and say base here, which means this must be the acid. But we have to figure out which protons on there are most acidic. So if you're using the pKa method, meaning you're simply just memorizing a bunch of pKa's, and there's nothing wrong with that, we would recognize that it's actually going to be this hydroxyl proton that is the most acidic. And that's the one that's going to get removed here, because this has a pKa of about 18. But let's say, for the sake of argument, you don't know the pKa. Okay, you did not memorize any pKa's. We can still look at the acid and figure out what are the most acidic protons in that structure. So let's look at this species. It has 3 methyl protons here. It has 2 protons there and 2 protons here. And we want to figure out which ones are most acidic, which ones are going to get removed by the base here. So when we're doing that, if we don't want to memorize pKa's, we can look at the conjugate base after the removal of a proton. So let's draw the conjugate base when the proton's removed from oxygen. That's going to put negative charge on oxygen. Let's look at the conjugate base of all the other species. One is going to put negative charge there. Another is going to put negative charge there. And the last one would put negative charge there. So if we want to know which protons are most acidic, we have to figure out which conjugate base is most stable. Because the more stable the conjugate base is, the easier it is to form, which means that the easier it is for the base to remove that proton that forms the conjugate base. The strength of an acid is always directly proportional to the stability of the conjugate base. So when we look at all these conjugate bases here, we just want to figure out where's that negative charge most stable. So here it's on oxygen, and in each of these it's on a carbon. Well, which one handles the negative charge better? Oxygen handles it better because oxygen's more electronegative, which means the negative charge is more stable on this oxygen, which means it's easier to remove this proton. So that's the most acidic proton. So even if you don't memorize the pKa's, you can still figure out which ones are most acidic by comparing the stability of the conjugate bases. All right, so let me remove these hydrogens here. I don't want them in my drawing. All right. So we know it's going to remove that hydroxyl proton. So what are the products going to be? The base is going to remove that hydroxyl proton. It's going to leave the 2 electrons behind, the one that belongs to oxygen and the one that belongs to hydrogen. And that's how we're going to form this conjugate base. Plus, nitrogen is picking up a hydrogen, so it's going to form the conjugate acid of that base, which is ammonia. So this is the conjugate acid. And this is the conjugate base. All right, so we figured out the products. We labeled everything. Now we're going to determine the direction of the equilibrium. And how are we going to do that? We're going to do it the same way we just compared where negative charge was more stable to figure out which proton's more acidic. So what I mean here is we're going to compare the stability of the species on the left, that's the base, versus the species on the right, that's the base. And we're simply asking ourselves, which one is a weaker base? The one that's a weaker base is going to form more because it's more stable. So what we're doing again is we're looking at these two things and we're trying to figure out which one's more stable. They both have negative charge. There's no resonance in either one of these. One has the negative charge existing on a nitrogen. The other has the negative charge existing on an oxygen. Well, oxygen's more electronegative than nitrogen. It's going to handle the negative charge better, which means this conjugate base is more stable. And since it's more stable, it's going to readily form more. This is more reactive. So that means the equilibrium is going to go towards the more stable conjugate base. If you're using the pKa method and you just want to memorize pKa's, well, the equilibrium is always going to go away from the more acidic acid. So if we want to compare the two acids in here, the alcohol versus ammonia, which one's more acidic? If we use the pK method, the alcohol has a pK of about 18. Ammonia has a pK of around 35 or so. Well, the lower the pKa, the more acidic. So that means it's going to be easier for this base to remove this proton to form this conjugate base and this conjugate acid. So that's another way of saying the equilibrium is going to go away from the more acidic acid towards the less acidic acid.